Good evening all. Last class we completed up to question number 23. So this class will start question number 24. So what is the question? So that the right circular cone of least curved surface area and the given volume has an altitude equal to root 2 times of the radius of the base. So we have right circular cylinder, so right circular cone we have to take. So right circular cone, we have altitude, that nothing but we can take it as h, altitude equal to h, radius we can consider as r. So what we need to prove here, means the altitude means h equal to root 2 times r I need to prove. So what to be minimize the least curved surface area. So CSA, we have to minimize the CSA, curved surface area we have to minimize. And what is given for us, volume has given, and what is given for us, volume of the cone has given. So volume of the cone equal to V equal to 1 by 3 pi r square h. This is given. So from this value I need to minimize the CSA. So if I am minimizing means I need to prove that h equal to root 2 times r, that is altitude equal to root 2 times the radius of the base, that I need to prove. So from volume is given for us. So from the volume V I can find the value of h. So what is the value V here? V equal to 1 by 3 pi into r square h. So this 3 will come this side. So 3V equal to pi into r square h. So our h value equal to 3V divided by pi into r square. H value equal to 3V by pi r square. So I need to find the CSA of the cone equal to pi RL. CSA of cone equal to pi RL. So they can consider CSA equal to S equal to pi into R into L, where L value is nothing but L value is here. So least L value is land height here. Land height formula we know that L equal to square root of h square plus r square. So that I will substitute here. So S equal to pi into R into root of h square plus r square. So root of h square plus r square means I have the value of h. So making square means I will get the h square. So surface area equal to S equal to, substitute the value here. So substituting, what will come, pi into r into root of h square value is making square here. So 9 into v square divided by pi square r power 4 plus r square will come. So find s square now. So s square equal to pi square r square, square root will go, the remaining values will be 9v square by pi square into r power 4 plus r square. Now multiply this pi square r square inside the root. So inside the bracket, so multiplying inside means I will get pi square r square into 9v square whole divided by pi square into r power 4 plus pi square into r power 4 will be the numerator. So pi square r square already multiplying with r square means pi square r power 4 will come. So we can cancel this pi square and pi square. We can cancel this r square. One of the r square will go. So the finally s square value will be 9v square divided by r square plus pi square into r power 4. So when we are going to find the critical point for this s square. So actually why we are finding for s square instead of finding s means when s is least, we can say that s square is also least. So to finding the critical point for s is equal to finding critical point for s square and proving that this s square is minimum, that is both are equal. So then I am going to now find the first derivative of this function ds square. So I am finding d by dr of s square So here first term 9v square is constant that we taken outside. 1 by r square, differentiating 1 by r square equal to minus 2 by r cube. Already we have learnt many times, we have reduced this. Now plus second term differentiation of r power 4 is 4r cube. So it will be 4 into pi square into r cube. If d by dr of s square equal to 0, this implies one of the term will move to right side. So I am taking this negative term to right side. So remaining will be 4 pi square into r cube equal to 18 times v square by r cube. So we can cancel by 2 table. So 9 will be remaining. So left side we can take it as 9v square. So 9v square equal to r cube will be multiplied here. We will get pi square, that is 2 times pi square r power 6. This is the value of 9v square. So we can keep this. Next we have to find the value second derivative. Second derivative means again differentiate this function with respect to r. So d square is divided by dr square of s square, that is differentiation. Here minus 18v square is constant. So minus 18v square is constant. Differentiation of 1 by r power 3, it's 1 by r cube, that is we can take it to numerator, it will get r power minus 3. Differentiation of r power minus 3 is minus 3 divided by r power 4, plus differentiation of second term, that is 4 into 3, 12 pi square r square, 12 pi square r square. Now we can substitute the value of 9v square here to get the critical point, to get that to check the whether it is maximum or minimum. So actually we need to substitute the r value here. Instead of substituting r value, I am going to substitute 9v square. So first to simplify this, so d square divided by dr square into s square equal to 18 into 3, 54. So 54 divided by r power 4 into remaining it will be v square. So v square plus here it will be 12 into pi square r square. Now I am going to simplify this. Now substitute, that is d square divided by dr square of s square at the point 9v square equal to 2 pi square r power 6 equal to, substituting that 54 by r power 4. Instead of v square we can substitute 2 pi square r power 6 divided by 9. So second term will be as it is 12 into pi square into r square. So we can cancel this 6 times. Here r power 4 cancelled means r square will come. So 6 2s are 12. 12 times pi square r square. Already 12 times pi square r square is there. That is equal to 24 times pi square r square. It is clearly greater than 0. So yeah, d, that is second derivative is greater than 0 means we can clearly say that s square is least. S square is least at 9v square equal to 2 times pi square r power 6. So what I need to prove? I need to prove actually the h equal to root 2 times r. So I need to find, I already found the value of h from the given volume. In that I am going to substitute this 9v square value and then I am going to prove that it is h equal to root 2 r. So what is the h value? Already we got h square or h equal to, we have got 3v divided by, we had pi into r square. H value we got 3v divided by pi into r square. So squaring this pi into r square. So squaring this, h square equal to 9v square divided by pi square into r power 4. So substitute the 9v square value here. So h square equal to 2 times pi square r power 6 divided by pi square into r power 4. So pi square cancel. This we will get r square. So h square equal to 2 times r square. H equal to root 2 times r. So that's only I need to prove. Clear? Next question, question number 25. Question number 24. So what is the question given? So that the semi-vertical angle of a cone. So we have a right circular cone. I have a circular cone here. So semi-vertical angle, this is called vertical angle. Semi-vertical angle means half of this angle. So this is a semi-vertical angle. So that I can take it as theta. Semi-vertical angle of the cone of the maximum volume. So volume to be maximized. We have to maximize the volume. Volume to be maximized. Given slant height. So what is given for us? Slant height is given. Slant height. So slant height of the cone equal to L. So L is given for us. And we have to maximize the volume. If we are maximizing volume with the given slant height means what we will get the semi-vertical angle, that angle theta equal to, we need to prove that tan inverse of root 2. That we need to prove the tan inverse of root 2. So now we know that theta will be the semi-vertical angle and theta clearly solution. So clearly theta will be, we can say that it is clear that theta belongs to the open interval 0 to pi by 2. Theta will be the first quadrant 0 to pi by 2. So similarly let r comma h comma l be the radius, h will be height and L will be slant height. L will be slant height respectively. So this will be our slant height L and this will be our H, this will be our R. So it is the right angle triangle. So that right angle triangle, I am going to use the Pythagoras theorem. Okay, I am going to use the right angle triangle concept here. So in right angle triangle, we can give a name for that. This will be A, this will be O, this will be B. So in triangle AOB, the value of sine theta in triangle AOB, so sine theta equal to, we have considered this as theta. So our diagram will become like that. We can change the diagram and write, if we have taken theta here, so this will be our A, this will be our O, this will be our B. OB we have taken as radius R. This AB we have taken as our length L, that is slant height L. OA we have taken as H. So sin theta equal to opposite by hypotenuse. So R by L will come. So from this I can write R equal to L into sin theta. R equal to L into sin theta. Similarly, I can use the cos theta concept. So cos theta equal to adjacent by hypotenuse. So H by L will come. So now what is the value of L? L equal, what is the value of H? H equal to L into cos theta. So here L is constant because L slant height is given for us. So theta is the function here. Now what to be maximized? We have to maximize the volume. So volume of cone equal to V equal to 1 by 3 pi into R square into H. So we know the value of R, we know the value of H from these two. So I can write the function V, the V in terms of theta. So V of theta equal to 1 by 3 into pi into R square. R square means L square sin square theta into H value is L into cos theta. So simplifying this, we will get pi by 3 into L cube into sin square theta into cos theta. This is the value of V of theta. This V of theta, I need to maximize the V of theta here. So I will take this as a function. I am going to find first derivative V dash of theta and I am going to make it as equal to 0, and then I am going to find second derivative substituting the critical point in the second derivative, and I am going to show that V double dash of the critical point is less than 0. That is the concept. Now we will find the differentiation of this, that is V dash of theta we will find now. Now differentiate this. So we will get V dash of theta equal to pi L cube by 3 is constant. It has two functions or in multiplication. So we will differentiate by using UV rule. Differentiation of sin square theta equal to 2 sin theta into differentiation of sin theta equal to cos theta, then second function will be cos theta plus second function sin square theta will be as it is. Differentiation of cos theta equal to minus sin theta. Now we will multiply this pi into L cube by 3. So we multiply this together, we will get here what will come here 2 times of sin theta into cos square theta. Here we will get minus of sin cube theta. We will get minus of sin cube theta. Now if v dash of theta equal to 0, if v dash of theta equal to 0, this implies this constant every term will become 0, equated to 0, constant will be equal to 0. So these two terms only will be remaining. This minus sin cube will be taken to right side. So taken to right side means remaining will be 2 times of sin theta into cos square theta equal to sin cube theta will come. So we can divide by sin theta both sides. So dividing sin theta means sin theta will go, sin square theta will be remaining. Now we can take the cos square theta to right side. So 2 times sin square theta by cos square theta, which is nothing but tan square theta. So we can write that tan square theta equal to 2. So tan theta equal to root 2. So what is the value of theta here? Theta equal to tan inverse of root 2. So theta equal to tan inverse of root 2 is the critical point. Now we will find the second derivative for this function. Then we will substitute the theta value here instead of tan inverse of root 2. Theta value by, we can replace theta value by tan inverse of root 2, or we can use the tan theta equal to root 2 in the second derivative. Now find second derivative, that is we are going to differentiate this function with respect to theta. So we have to apply UV rule for this again. So V double dash of theta equal to pi into L cube by 3 will be outside. So 2 into differentiation of sin theta equal to cos theta into second function cos square theta plus 2 times, that 2 is common for both, so 2 multiplying here 2 times first function will be as it is, differentiation of cos square equal to 2 times cos theta into minus sin theta. Then second function differentiating this, we will get 3 times sin square theta into cos theta. Now we'll simplify this. So we will get outside pi into L cube by 3. This will be 2 times cos cube theta. 2 times cos cube theta. 2 into 2 4, minus 4 will come. So minus 4 into sin square theta cos theta, already minus 3 into sin square theta cos theta will be there. So pi into L cube by 3 into 2 times of cos cube theta, adding these two we will get minus 7 times sin square theta cos theta will come. This is the value of V double dash of theta. Now we need to check this V double dash of theta is less than 0 or not at the point theta equal to tan inverse of root 2. So already we have tan theta, we will keep this as it is, or we can keep it as equation number 1. Already we have tan theta equal to 2, that is sorry, tan theta equal to root 2. This implies we can write that tan square theta equal to 2. This can be written as sin square theta by cos square theta equal to 2. So sin square theta will be, value will be sin square theta equal to 2 times of cos square theta. This is equal to our tan theta equal to root 2 or theta equal to tan inverse of root 2. So instead of substituting this, I can substitute this in the second derivative. Second derivative, instead of sin square theta, I am going to replace this now. Now replacing sin square equal to 2 cos square, we will get outside will be pi into L cube by 3, inside 2 times cos cube theta minus 7 into 2 times cos square theta into cos theta. So the finally we will get pi into L cube by 3. Here 7 into 2 14 cos cube theta. Here 2 cos cube theta. Adding both we will get minus 12 cos cube theta. Cancelling means minus 4 times pi into L cube into cos cube theta. It is clearly less than 0. So v double dash of theta less than 0 means we can say that v of theta is maximum. So v of theta is maximum at theta equal to tan inverse of root 2. This only we need to prove. The vertical angle equal to tan inverse of root 2. We proved now. Next question, same model question. Question number 26. Find so that the semi-vertical angle of right circular cone. So same shape right circular cone we can draw. Semi-vertical angle we can take it as theta or alpha, whatever it is for our convenience. We am taking here it as theta. So semi-vertical angle theta. The semi-vertical angle I need to show that it is equal to sine inverse of 1 by 3. Actually question is semi-vertical angle of right circular cone of given surface area. So what is given for us? Surface area is given. Surface area equal to S equal to what is surface area means total surface area actually. So total surface area is pi RL plus pi R square. So the surface area is given for us this, and we have to maximize the volume. We have to maximize the volume. Maximize the volume. So what we need to prove if we are using this given surface area maximizing the volume means the semi-vertical angle theta equal to, I need to show that sine inverse of 1 by 3. Sine inverse of 1 by 3 we need to prove. Clear? So now solution, usually we will use the usual notations, slant height equal to L, h equal to height equal to h, and radius equal to r. So I am taking that let L, R and H be the slant height, R means radius, so slant height, radius, and H equal to height of the right circular cone or of the cone of the RS cone. Right circular cone, RS cone, RC cone, right circular cone. So now what is the volume, the surface area here? Surface area first we will write that. So pi into R square, pi R square plus pi into R into L. L value we know that is root of H square plus R square. It is given. So from this I am finding the value of H. After that H value I am going to substitute in the volume. So what is the value of H? Before that bring the pi R square to left side. So we will get S minus pi R square. Then divide by pi R. We will get root of H square plus R square. So the squaring both sides. Before squaring both sides we will remove we will simplify this. So this implies root of H square plus R square equal to, separating that S by pi R minus pi R cancel, R alone will be remaining. So now we want to remove the square means we have to squaring both sides. So squaring both sides we will get R square plus H square or H square plus R square equal to, use A minus B whole square formula. So A square means S square by pi square R square plus R square minus 2AB. So minus 2AB 2 times S divided by pi R into R. So these two will get cancelled. We will get this alone remaining. Now we are going to take the R square to right side, or we can cancel here itself the R square. So my H square will be S square by pi square r square minus 2s by pi. This is the value of h square now. So now we will substitute this value into the volume, or we can find the value of h from this. So h equal to, we will get square root of s square divided by pi square into r square minus 2s by pi. Now what we have to maximize? We have to maximize the volume. So the volume equal to 1 by 3 into pi r square h. So substitute that h value here. So 1 by 3 into pi r square into h value equal to s square by pi square r square minus 2s divided by pi. So same concept I am going to use here. If v is maximum, if v is maximum, v square is also maximum. If v is maximum, v square is also maximum. So I am going to find v square from that to avoid the root here. So I am going to squaring this. So squaring means I will get v square equal to, outside it will be pi square r power 4 by 9. So square will go. So s square divided by pi square r square will be there. So I am going to take LCM here. So totally pi square r square as common denominator I am going to take. So if I want to take common denominator pi square r square means I need to multiply with pi r square in numerator and denominator. So this will be 2 times pi into r square into s will come. Now we can cancel this pi square, r square will cancel. Next I can multiply this r square by 9 inside. So v square equal to, already it is s square. So s square into, multiply this r square inside, s square r square divided by 9 will come. Now multiply r square by 9 to in second term. So we will get 2 times s into pi into r power 4 divided by 9. This is the value of v square in terms of r. So that I am writing as v square in terms of r, v square of r. So now I am going to find the first derivative of this, that is d by dr of this v square in terms of r. Differentiation of this, we will get 2 into r into s square by 9 minus differentiation of r power 4, remaining are all constant because s is surface area it is given. So differentiation of r power 4 is 4r cube, already 2 there. So 8 into s into pi into r cube by 9. Now I need to find critical point, mean first derivative equal to 0. So if d by dr of v square by r equal to 0, that implies this term equal to 0. So this term will be one of the negative term will be taken to right side. So positive term 2 into r into s square by 9 equal to 8 into s into pi r cube divided by 9. 9 I can cancel. I can cancel 1 2 is to 4 times, and one of the s will be cancelled. So left side will be, what will be remaining, r and s will be remaining. Right side will be 4 into pi r cube will be remaining. One more r also we can cancel. R cancelled means we will get r square alone. So left side s equal to 4 pi r square will be remaining. So from that I can find the value of r. It is r square. From that I can find the value of r. So r equal to s by 4 pi square root of. This is the critical point for us. Now we will find the second derivative. So second derivative means we have to differentiate this again with respect to r. So that is d square r by dr square into v square of r. So differentiation of this, it is only r available. So differentiation of r equal to 1, that is remaining will be 2s square by 9 will be remaining, minus differentiation of r cube equal to 3r square, already 8 is available. So 24 into s into pi into r square divided by 9. This I can cancel. What I can cancel means 1 3 times I can cancel, 8 times will be remaining. So our second derivative is 2 times s square by 9 minus 8 times s into pi r square divided by 3. Now we will find the second derivative at the point r equal to root of s by 4 pi. Second derivative, we have to replace this critical point here instead of r. Then we have to show that it is less than 0 because it is what is given volume to be maximum volume. So this would be less than 0 now. So I'm going to substitute here. Now substitute the second derivative value. Second derivative v double d square r by ds square. So second derivative will come. So d square by d r square at of v square of r, instead of r equal to s by 4 pi, or you can substitute s equal to 4 pi r square in this equation. So s square means I will get 16 into pi square into 16 into pi square into r power 4 divided by 9 minus, we will get 8 into s value is 4 into pi into r square. Already pi into r square is available, divided by 3 will come. So now we can multiply this inside. So 2 into 16, 32 times pi square r power 4 by 9 minus 8 fours are 32 by 3 times pi square r power 4. So we are taking LCM, that is we have to multiply by, so or we can take what is common here, 32 into pi square r power 4 by 3 is common, remaining it will be 1 by 3 here, it will be 1 only. So simplifying this, we will get minus of 32 pi square r power 4 divided by 2 by 3 will come. So 2 times minus 2 by 3 will come. So into 2 multiplied divided by 3. Anyhow, it is less than 0. So second derivative is less than 0 means we can say that v square of r is maximum at the point s equal to 4 pi r square. So we have to write that v square of r is maximum at s equal to 4 pi r square. So we have to find the what we have to prove, semi-vertical angle equal to sine inverse of 1 by root 3. So 1 by 3. So already we have h value. So h equal to square root of s square divided by pi square r square minus 2s divided by pi. The s value, this I can simplify the h value. So how I am going to simplify means this can be written as s square divided by pi square r square can be written as pi into pi r square minus 2s by pi, because this pi r square value I am going to use s by 4 here. So my h value equal to root of s square divided by pi will be outside, pi r square value equal to s by 4. So s will come here, the 4 will go to the numerator. So minus second term will be 2s by pi. So one of the s will get cancelled. So 4s by pi minus 2s by pi equal to root of 2s by pi. So h value we found, that is equal to 2s by pi. Now we know that from the triangle, actually in the cone, it is a quite circular cone given, it is the angle theta. So already we have, it is L, it is H, it is R. So now I am going to prove that sine that is theta equal to sine inverse of 1 by root 3. So I need the sine theta value for this triangle. So this triangle sine theta equal to theta here. So opposite side equal to r and hypotenuse equal to L. So sin theta equal to r by L will come. So r value we can keep as it is, and L value already we know that is L equal to root of h square plus r square. Now h value we found, r value also we can use from this table. So from this s equal to 4 pi r square. So r equal to what will come, already we have written r equal to square root of s by 4 pi divided by root of h square means square of this, that is 2s by pi, plus r square means square of this, that is s by 4 pi. Now simplify this, we can take common root s by 4 pi. We can going to simplify means we have to multiply here 4 numerator and denominator. 4 into 2 8s plus 1s, 9s will come. 9s divided by 4 pi. This 4 pi cancel. So remaining will be s by 9s. So one of the s will cancel, 1 by 9 will be remaining, that is equal to sin theta equal to root of 1 by 9. This implies sin theta equal to 1 by 3. This implies theta equal to sin inverse of 1 by 3. The theta nothing but semi-vertical angle. This only I need to prove. Clear? Thank you. Next class we will start the second volume integrals chapter. Thank you all.